We can write tan cube 2x in the form of tan square 2x into tan 2x. You can multiply 1 by 2 inside. If you multiply, you are going to get secant cube 2x divided by 6 minus secant 2x divided by 2 plus c. Since you are having the power is minus 1, if you take to the numerator, it will be a p plus q, which is in the form of minus 1 minus 3, which is a negative. Cos 2x can be written in terms of 4 types. One in terms of cos and sine, one in terms of only sine, one in terms of only cos, one in terms of only tan. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics Faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So in the last session, we have learnt many problems on trigonometric identities. Dear students, in today's session, session number 6 you are going to have, and from your NCERT chapter number 7, which is going to be called as integrals. And what are all the topics under this session we are going to study, dear students? It's nothing but some more problems using the trigonometric identities. Now, trigonometric identities is nothing but you know how to substitute sine squared theta plus cos squared theta is equals to 1, isn't it? So, sine squared theta plus cos squared theta is equals to 1. 1 plus tan squared theta is equal to secant squared theta. 1 plus cot squared theta is equal to cosecant squared theta. So, based on this, we will be moving on to solving the problems by a trigonometric identities also and also by substitution method. Now, we will be moving on to the problems of integrate tan cube 2x into secant 2x. Dears, we can write tan cube 2x in the form of tan square 2x into tan 2x, which will be giving you a tan cube 2x only. So, I am going to split this one and writing symbolically integral of tan squared 2x into tan 2x into secant 2x. I hope you got this step. I have splitted this tan cube 2x as like this. Now what I am going to do, I am going to take this tan squared 2x in the form of 1 plus tan squared theta is equal to secant squared theta. Otherwise, you can have secant squared theta minus 1 can be written as tan squared theta. Where, dear students, theta replaces here 2x. Therefore, I can write this whole term as secant squared 2x minus 1, correct, into tan 2x as it is into secant 2x. Why I am doing so? Because I can do here substitution method. If I am going to substitute here secant 2x is equals to t, you know differentiation of secant is nothing but secant into tan. Already you are getting here secant into tan. Therefore, let me move on to the substitution method. Let secant 2x is equal to t. So, differentiate this with respect to x. Secant 2x differentiation gives you secant 2x into tan 2x into tan 2x. Again, 2x differentiation, because it is a chain rule. 2x differentiation will be giving you 2 is equal to dt by dx. Now, taking dx to this side, 2 into secant 2x into tan 2x into dx is equal to dt. Otherwise, secant 2x into tan 2x into dx is equal to dt by 2. Now, substituting this as dt by 2, secant 2x into tan 2x into dx as dt by 2 and substituting secant 2x as t. So, what happens to this condition here? Integral of secant squared is there. So, secant 2x we know that it is t squared minus 1 into this is nothing but dt divided by 2. 1 by 2 I am going to take outside the integral since it is a constant. Now, dear students, integrating this separately is very easier for you, which will be given 1 by 2 into integral of t squared into dt minus 1 into dt. Now, after integrating this, you are going to get the answer. T squared integration is t cube divided by 3 minus 1 into dt integration is t plus c. Now, substituting back to t, you are getting, we have substituted t as secant 2x. So, secant 2x t cube is there, whole cube divided by 3 minus secant 2x plus c. You can multiply 1 by 2 inside. If you multiply, you are going to get secant cube 2x divided by 6 minus secant 2x divided by 2 plus c. And this is your answer, dear students. I hope you got this one, how to do by using the trigonometric identity and also by using substitution method. Now we'll be moving on to the next problem. Integrate tan to the power of 4x. Dear students, you can write this tan to the power 4x as, see, I am writing like this. You know already tan squared theta can be written as secant squared theta minus 1, just now we have seen. Now accordingly, I am going to write this one as tan squared x into tan squared x. So here I am going to write tan to the power of 4x as tan squared x into tan squared x, which is nothing but tan to the power of 4x into dx. Symbolically, now 1 tan squared dx I am going to substitute it as secant squared x minus 1 according to the formula of a trigonometric identity, which is secant squared x minus 1 into tan squared x into dx. I hope you got this one. So here I am going to take multiply tan squared x inside. So what happens? Secant squared x into tan squared x. Okay, I am separating the integral into dx minus integral of tan squared x into dx. I hope you got this step. Again substituting back to that. So integral of secant squared x into tan squared x into dx minus this I can substitute as secant squared x minus 1 according to the trigonometric identity into dx. Now what happens to this condition? You are getting here, see this, if I substitute here a tan x differentiation is nothing but a secant squared x, isn't it? So therefore for the first integral I am going to do the substitution method. For this integral I am going to segregate because integral of secant squared x you know already. Therefore here for the first integral, for this I am substituting, what is that? Let tan x is equal to, for that I am substituting let tan x is equals to t, differentiate this with respect to x. If you differentiate this with respect to x, you are going to get secant squared x into dx is equal to dt. Now substituting this to this condition, which happens, which will be equal to, see, secant squared x into dx is nothing but dt and tan squared x is nothing but t squared because we have substituted tan x as t minus, see, this I am multiplying inside minus integral of secant squared x into dx minus into minus, see, minus into minus is plus 1 into dx, integral of 1 into dx. Now what happens to this condition? You can have t squared integration is nothing but t cube divided by 3 minus here secant squared x integration is nothing but tan x plus 1 into dx integration is x plus c. Now substituting back to t, you are getting tan x whole cube, which is tan cube x divided by 3 minus tan x plus c, and this is your final answer. I hope you got this one, how to do by using the trigonometric identity and also by substitution method. Now we'll be moving on to the next problem, dears. What they've asked: sine cube x plus cos cube x divided by sine squared x into cos squared x. You need to integrate this one. Now let me write this symbolically first. Integral of sine cube x plus cos cube x divided by sine squared x into cos squared x into dx. What I am going to do, I am going to segregate this separately. Integral of sine cube x divided by denominator as it is sine squared x into cos squared x plus into dx. I am separating this. Integral of cos cube x divided by sine squared x into cos squared x into dx. Now what happens to this condition? See, sine squared x here, sine squared x will get cancelled. Remaining is in the numerator sine x into dx divided by cos squared x, right? So plus again here 1 2 term of cos squared x will get cancelled. Remaining is cos x divided by sine squared x into dx. Now dear students, I am going to write it again this one cos x separately as like this, integral of sine x divided by cos x into 1 over cos x. You can observe in the denominator dear students, cos x into cos x is nothing but cos squared x you are getting. Similarly, I am going to split this one sine squared x as sine x into sine x. Into dx I am writing, which implies, so plus integral of, again same here I am doing, cos x 1 by sine x into 1 over sine x into dx. Now again here writing this, sin x by cos x gives you tan x into 1 by cos x is nothing but secant x into dx plus cos by sin is nothing but cot x and 1 by sin is nothing but cosecant x into dx. Dears, you are having this directly integration. Integral of secant x into tan x is nothing but secant x. Integral of cosecant x into cot x is nothing but minus cosecant x. So minus cosecant x plus c. That's it. And this is your final answer you are getting after simplification. I hope you got all the steps. Now we'll be moving on to the next problem. Integrate cos 2x plus 2 sin squared x divided by cos squared x. Dears, you know numerator it is in terms of here sin squared x. Cos 2x I can write it in terms of sin 2x as c. Cos 2 theta formula is given by 1 minus 2 sin squared theta. Correct? Now dear students, you are having cos 2 theta is 1 minus 2 sin squared theta. You are having cos 2x here. So cos 2x will be what? Integral of cos 2x I can substitute as 1 minus 2 sin squared x, where theta replaces x here, plus 2 sin squared x, right? Divided by cos squared x into dx. Now dears, you can have here cancellation of minus 2 sin squared x plus 2 sin squared x, and remaining in the numerator is 1 divided by denominator is cos squared x into dx. Dears, you are having 1 by cos squared x into dx is nothing but secant squared x into dx. You know already secant squared x into dx is integration is nothing but tan x plus c. That's it. And this is easier problem which will be asked for a 2 marker or 3 marker. Now we'll be moving on to the next problem, dears. Integrate 1 over sin x into cos cube x. Dears, if you substitute here in terms of cos or in terms of sin, you will never get 1 by cos or 1 by sin. So what I am going to do here, since you are having the power is minus 1, if you take to the numerator it will be a p plus q, which is in the form of minus 1 minus 3, which is a negative. Correct? Minus 1 minus 3 is minus 4. So therefore, multiplying and dividing the numerator and denominator by secant to the power of 4x I am doing here. So therefore, here you can have integral of, see, secant to the power of 4x, I am multiplying and dividing by secant to the power of 4x, okay? Cos cube x into secant to the power of 4x into dx. Dear, if you cancel this one, you will go back to the same step. Now here, because I can bring to the form of either the tan and secant, because tan squared x can be written as secant squared x minus 1. In that form, I am going to bring it this one. So here, you can have, this will be equal to integral of secant to the power of 4x divided by sin x into cos cube x. This 1 by secant to the power of 4x can be written as, or 1 by cos to the power of 4x, isn't it, into dx. Now here, one term of 3 terms of cos will get cancelled. Remaining is numerator secant to the power of 4x as it is divided by sin x divided by cos x. Now what is sin x divided by cos x, dears? Sin x divided by cos x is nothing but tan x. Therefore, you can have, this will be equal to integral of secant to the power of 4x divided by sin x by cos x is nothing but tan x into dx. Now, you can have secant to the power of 4x as secant squared x into secant squared x, correct? Divided by tan x into dx. Now again, you can substitute as secant squared x as 1 plus tan squared x. So 1 plus tan squared x into secant squared x, 1 secant I am substituting like that, divided by tan. Why? Because I can do here substitution method. If I differentiate tan x, I am going to get it secant squared x. So therefore, here substituting, let tan x is equals to t, let tan x is equals to t. So differentiate this with respect to x. I am getting secant squared x into dx is equal to dt. Dears, you can take that one which will be equal to, which implies 1 plus tan squared. 1 plus tan squared is nothing but t squared. So 1 plus t squared into, see, secant squared x into dx, we got it as dt divided by tan x, we have substituted as t. That's it. Now again integrating this separately, 1 by t into dt plus integral of t squared by t into dt. Now again this one, integral of 1 by t into dt plus here one term t it will go, so remaining is t into dt. You know already 1 by t into dt integral is nothing but log of modulus t plus t integral is nothing but t square divided by 2 plus c. Now substituting back to t, you are getting log modulus of tan x plus tan squared x, because you are having t square divided by 2 plus c. And this is your final answer, dear students. I hope you got this step, how to multiply and divide by, why you need to multiply and divide by secant to the power of 4x. Now we'll be moving on to the next problem, dears. They have asked integrate cos 2x divided by cos x plus sin x whole squared. Dears, you know already cos 2x can be written in terms of 4 types. One in terms of cos and sin, one in terms of only sin, one in terms of only cos, one in terms of only tan. Now here, since you are having denominator in terms of cos and sin, numerator cos 2x, I am substituting the formula as like this. Integral of cos squared x minus sin squared x is nothing but cos 2x divided by this, I am substituting accordingly. Denominator as it is, cos x plus sin x whole squared into dx. Now this is according to a squared minus b squared. What is a squared minus b squared? A plus b into a minus b. Therefore, you can write the numerator as a plus b, which is cos x plus sin x, into a minus b, which is cos x minus sin x, divided by denominator as it is, cos x plus sin x whole squared into dx. Now what happens, dears? Yes, your guessing is right. One term of cos x plus sin x will get cancelled. Now remaining is numerator cos x minus sin x divided by denominator, one term is remaining, cos x plus sin x into dx. Dears, if you now differentiate the denominator, obviously you are going to get the numerator, because cos x differentiation is minus sin x and sin x differentiation is plus cos x. Therefore, here I am going to do the substitution. Let denominator, that is cos x plus sin x, is equal to t. Now differentiate this with respect to x. You are getting cos x differentiation is minus sin x plus sin x differentiation is cos x. Dt by dx, dx can be taken to this side, is equal to dt. Otherwise, cos x writing first and negative writing next, sin x into dx is equal to dt. Now substituting the numerator as gt and the denominator will be is equal to t, which implies that numerator will be is equal to dt. We can observe cos x minus sin x into dx as dt divided by denominator is nothing but cos x plus sin x as t. Now here you can have 1 by t integration is nothing but log of mod t plus c. Now what is log of mod t? Log of modulus of substituted as cos x plus sin x plus c. Now this is your final answer you are going to get after simplification. Now we'll be moving on to the next problem. Integrate sine inverse of cos x. Now dears, you cannot substitute here cos x because sine inverse you are having. So what I am going to do here, you know, according to the trigonometric functions, sine inverse and sine will go and remaining whatever inside the angle, isn't it? So writing this cos x in terms of sine, you know, according to the standard angle, you can write it as sine of 90 minus theta is equal to cos theta. Now here, in place of theta, you are having x. So what I am going to do here, which implies integral of sine inverse into, see cos x I am writing sine of 90 minus x. Okay, I hope you got this one. Now sine and sine inverse will go, dx is there, which implies integral of pi by 2 minus x into dx. Now you can separate this integral. Pi by 2 anyway it is a constant. Pi by 2 integral of 1 into dx minus integral of x into dx. Therefore, you can write this answer will be pi by 2 into integral of 1 into dx is nothing but x minus x integral is nothing but x squared divided by 2 plus c. And this is your final answer you are going to get after integration. I hope you understood this one. Now we'll be moving on to the next problem. Integrate 1 over cos of x minus a into cos of x minus b. Dear students, here let me subtract the numerator this. What happens? X minus a minus of x minus b. What happens to this? X minus a minus x plus b. So therefore, plus x minus x will get cancelled. Remaining is b minus a. So what I am going to do here, I am going to multiply and divide sine of b minus a. Sine of b minus a, which is a constant. So 1 over sine of b minus a here, I am writing. So sine of b minus a, sine of b minus a will get cancelled. You are going to remain with the same. For the simplification, I am doing this. Cos of x minus a into cos of x minus b, denominator into dx. Now dears, here I can write it as 1 over sine of b minus a as it is. Now integral of this can be written as, instead of b minus a, I can substitute it as x minus a minus of x minus b, isn't it? As we have done there, divided by cos of x minus a into cos of x minus b into dx. Now dears, you can have, this is in the form of sine of a minus b. What is sine of a minus b? Sine of a minus b given by the formula sine a into cos b minus cos a into sine b. Therefore, capital letter A replaces x minus a, capital letter B replaces x minus b. Accordingly, we are going to write as sine of a minus b, integral of this can be written as sine a into cos b minus cos a into sine b, which is x minus b, divided by cos of x minus a into cos of x minus b into dx. Now dividing each, I am going to divide each here. So what happens? Integral of 1 over sine of b minus a in the denominator, integral of separating this sine of x minus a into cos of x minus b divided by denominator is cos of x minus a into cos of x minus b minus into dx I am writing because I am separating this integral minus integral of cos of x minus a into sine of x minus b, denominator as it is, that is cos of x minus a into cos of x minus b into dx. Now what happens to this? You are getting cancellation with cos of x minus b, cos of x minus b. Here cos of x minus a, cos of x minus a. Now dear students, after doing a cancellation here, you are getting sine of x minus a 1 over, as it is I am writing, sine of b minus a into integral of sine of x minus a divided by cos of x minus a is tan. Sine by cos is tan of x minus a into dx minus, similarly here sine by cos gives you tan of, what is this, x minus b into dx. Now dears, you know already tan x integral is nothing but log of secant x, that is a mod secant x. Therefore, writing that 1 by sine of b minus a, integral of this giving you log of, open the bracket, because 1 by sine of b minus a will be multiplied throughout, modulus of secant of x minus a divided by coefficient of x is 1. Coefficient of x is 1. So, neglecting that, anyway, anything divided by 1 will be the same thing. So, this also log of modulus of secant of x minus b. Correct? Plus c. Now, dear students, log m minus log n gives you log m by n, which will be implies 1 over sine of b minus a is log m minus log n is nothing but log m by n. N is nothing but secant of x minus b plus c. Otherwise, see, secant of x minus a can be written as 1 over cos. This can be written as 1 over cos. This will go to the numerator. Other answer also can be written as, which implies 1 over sine of b minus a into log of. So, how I can write this one as cos of x minus b. Cos of x minus b. Again, secant of x minus a can be written as 1 over cos of x minus a plus c, and this is your answer. I hope you understood this one, how to solve by doing a multiplication of sine of b minus a to the numerator and the denominator. Now, you got how to solve this problem. Thank you, dear students. I hope you understood this session and enjoyed how to solve the problems on a trigonometric identities. In the next session, we'll be moving on to a problem solving on integration by other method. Keep watching. Have a nice day.